isotopes, or radioisotopes as you may know them, come up in GCSE physics, GCSE chemistry, GCSE science, no matter what you're doing. So what actually is an isotope? What do we mean by isotope? We mean the atom of the same element which has a different number of neutrons. So hopefully you already know the difference between the different parts of an atom. So we've got protons, electrons, neutrons, we've got protons and neutrons in the nucleus, and when an atom has different numbers of neutrons, that gives rise to isotopes, and they do occur naturally. They occur, as I've got here, image of a different constellation. They can form naturally in stars due to different amounts of neutrons floating about in the fusion soup. Different life stages of stars, you can get all sorts of things happening, all sorts of radioactive reactions, and instabilities can add or subtract neutrons from the nuclei. But we also can produce radioisotopes here on Earth through nuclear fission by adding in neutrons into a nucleus and then causing a chain reaction of radioactive decay. So the important thing to remember is different numbers of neutrons, and what you'll have to do is figure out how many neutrons a different element has. So for that we need to remember the periodic table notation for different elements, where we have E, the chemical symbol, excuse my terrible handwriting, M for the mass number, Z or A for the atomic number, and those two might be the other way around, just double check. Usually you're looking for the bigger one being the mass number. And so if we've got something like carbon-14 for radioactive dating, you're probably familiar with that, for dating fossils, and we've got carbon-12. And so we might need to know what are the different numbers of neutrons, and the way to do that is the number of neutrons, N, is the mass number subtract that atomic number. So for carbon-14 we're doing simply 14 take away 6, whereas in carbon-12 we do 12 minus 6. So carbon-14 has 8 neutrons, whereas carbon-12 only has 6. Same thing if we consider oxygen-16 versus oxygen 18, not 16 again. We do 18 minus 8, and that gives us 10, or 16 minus 8 gives us 8 neutrons. So in our stable oxygen isotope we have 8 neutrons, but in radioactive oxygen or heavy oxygen we have 10 neutrons there. What did I just say? I said isotopes. Anyway. And then in my favourite we have stable uranium-238 versus the radioactive uranium-235. So again we do the same thing, the mass number, the big number, subtract the atomic number of uranium, and for those different amounts we're going to get 146 for the heavier uranium and 143 neutrons for the lighter uranium. Alright? Easy peasy.